All right, let's dive into something pretty cool today.
Yeah.
We're going to be talking about how camera image quality is tested and validated.
Oh, cool.
You might think, a technical presentation on this wouldn't be super interesting.
Yeah.
But trust me, this one, it's in Mandarin.
Oh, wow.
And it's packed with these real-world examples that are going to totally change how you see your smartphone camera.
I always think it's so fascinating to get a peek behind the curtain.
Yeah.
And this one feels like it was actually for internal training.
Oh, really?
At a company. So we're really getting a glimpse of how the engineers and the product managers make sure that we get these incredible photos and videos that we've come to expect from our cameras.
That's like we've got backstage passes to see how the magic happens.
Yeah.
So today, our goal is to really break down the key processes involved in making these amazing images.
I love it.
And you don't need to be a tech whiz to follow along.
No, absolutely.
So let's jump right in.
Okay.
So it all starts with
yeah, why even bother?
Why bother testing?
Why go through all this trouble?
Exactly.
Well, the presentation really emphasizes that it goes beyond just meeting basic specs on a sheet.
Right.
It's really about making sure that your camera is going to perform amazingly in all kinds of situations.
Yeah.
Think about low light or when there's a big difference between the lightest and darkest areas.
So it's not just about taking a decent photo in perfect lighting conditions.
Right, exactly.
It's about making sure that your camera can handle pretty much anything you throw at it.
Absolutely, yeah. And catching those potential issues early on is really key.
Okay.
The presentation specifically mentions things like avoiding weird color casts in your photos.
Okay.
Imagine everything's a little too green or yellow, and then there's noise, which can make a photo look grainy, especially in low light.
Right. So you're telling me there's a reason why some photos look super smooth even when they're taken in? Like a dim restaurant or something?
Exactly. Yeah. Rigorous testing helps identify and address these problems before they ever even reach your camera.
That's amazing.
And speaking of lighting, the presentation dives into how light and camera technology actually work together.
Okay.
And how different kinds of light can affect the way your camera captures an image.
Like light is the language of cameras.
Yes.
Right?
Exactly. It's how they see the world.
Yeah.
So to understand this language, we need to look at two key parts of a camera.
Okay.
The CMOS sensor, which is like the camera's eye, captures the light.
Okay.
And then you have the ISP, or image signal processor, which acts like the camera's brain processing that information from the sensor.
So it's like a partnership.
Yes.
The eye sees and the brain interprets.
It is.
The presentation mentions using 3 specific types of light sources in lab testing: ALA, CWF, and D65.
Yes.
What are those all about?
Well, they each simulate a different lighting condition that we encounter on a daily basis. So ALA replicates that warm yellowish light of a traditional incandescent bulb, while CWF mimics the cooler bluish light that you find in offices.
Okay.
And then D65 aims to reproduce the average midday sunlight in North America, which is a more neutral white light with a hint of blue.
So they're testing how the camera's eye perceives colors under these different lights.
Exactly.
But how do they measure and compare these different kinds of light?
That's where color temperature comes in, and that is measured in Kelvin.
Oh, Kelvin.
Yes. And it describes how warm or cool a light source appears.
Got it.
So think about the warm glow of a candle flame compared to the cool blue of a welder's torch.
Okay, yeah.
So each light source has its own specific color temperature. And controlling this during testing ensures that they're getting consistent and accurate results.
Makes sense. So the next time I'm struggling to take a good photo in a dim restaurant, I'll know that my camera is working hard to interpret the light it's receiving. And to do this, they actually test cameras in a very controlled environment.
Yes, they do.
The presentation takes us inside a testing lab called the IQL lab.
Ooh, very high tech.
Yeah, what's it like in there?
So picture a specialized light box with adjustable light sources and a diffuser to spread the light evenly.
Yep.
A test chart sits right in the center, and the camera is placed at a very specific distance to guarantee those accurate measurements.
So they're trying to eliminate any variables that could mess with the results.
Exactly.
But what about real-world situations?
Yes.
Do they ever test cameras outside of the lab?
They do. There's a whole section dedicated to what they call IQ field testing.
Okay.
Where they take the cameras out into the real world
to
see how they perform.
Okay.
But before we get there, I think we should look at the key tests that they conduct inside the IQLA lab first.
Okay, let's take a closer look at those tests and the tools they use to get those precise measurements.
Sounds good. So first up, we've got the equipment. They use this 4-color light source box, standardized test charts, and then some specialized software called Imatest.
Okay.
And this software is used for like in-depth analysis. The key here is that these tools meet international standards.
Okay.
So that means that their tests are really consistent and reliable.
So there's a method to the madness.
Yeah.
It's not just someone like looking at a photo and saying like, yeah, this looks good enough or this doesn't look enough.
Exactly. Yeah. And they actually mention that they use Sony's testing methodologies as a benchmark.
Wow.
So it seems like they're really looking at what the best in the industry are doing.
Well, yeah, it makes sense to learn from the experts, right?
Exactly.
So now let's talk about sharpness.
Okay.
The presentation introduces something called MTF, which is modulation transfer function.
You know how people always talk about resolution and megapixels?
Yeah.
MTF is a way to actually objectively measure that sharpness.
Okay.
Specifically, they look at something called MTF 50p, which tells you how sharp the edges and the fine details are in an image.
So a higher MTF 50p score.
Yeah.
Means a sharper picture.
Exactly. Yeah, a camera with a high MTF 50p can capture those tiny details.
Yeah, but
even when you zoom in, like imagine the individual hairs on a dog's coat.
Right.
Or the texture of a brick wall.
Yeah.
And to measure this, they use something called the slanted edge method.
Okay.
But we won't go too deep into the technical stuff on that one.
I appreciate that.
Yeah.
So what I'm hearing is that there's real science behind all this.
Absolutely.
It's not just like this looks sharp.
No, there's a number to it.
Exactly.
Yeah.
So what else do they look at?
Okay, so next up, we've got dynamic range.
Okay.
And that's the camera's ability to show detail in both the really bright and the really dark areas of a scene.
So it's like the difference between a picture where the bright parts are all washed out.
Yes.
And the dark parts are just like black blobs.
Exactly.
Versus a picture where you can see detail everywhere.
You got it. So, like, imagine taking a picture of someone standing in front of a sunset.
Okay.
A camera with good dynamic range can capture both the bright colors of the sky and the details in the person's face. Even though one's really bright and the other's in shadow.
So it's like the camera is juggling light and shadow.
Yes.
To make sure that nothing gets lost.
And how do they even test for that in the lab?
So they use this test chart with a range of gray patches.
Okay.
And each one of these patches represents a different level of brightness.
Okay.
So by analyzing how well the camera captures these patches, they can figure out its dynamic range.
Okay.
And this is where something called the tone curve comes in.
Okay, the tone curve. Now that sounds kind of mysterious.
It is a little bit.
What does it do?
So think of it like this. The tone curve is kind of like fine-tuning the brightness of each part of the image.
Okay.
To make it look more like what our eyes actually see.
Right.
It's kind of like the camera is using its brain to make sure that the picture looks realistic. So it's about striking this balance between capturing all the light information, but also making sure that it still looks natural to us.
Exactly.
Yeah.
And they actually show a really cool example in the presentation.
Oh, nice.
It compares a photo with high dynamic range and one with low dynamic range.
Okay.
And the difference is amazing. The high dynamic range just has so much more detail and depth.
Okay.
And the low dynamic range just looks flat and lifeless.
Wow. Can see why that's so important.
Yeah, it makes a big difference.
So we got sharpness. We've got dynamic range.
Yeah.
What other obstacles do camera makers have to overcome?
So they also talk about a couple of challenges that can come with lenses.
Okay.
Things like vignetting and color shading.
Vignetting, I feel like I've heard that before.
Yeah, it's a common one.
But I'm not entirely sure what it is.
It's when the corners of an image are darker than the center.
Oh.
And it happens because of the way that light travels through the lens. Sometimes it can actually give photos a sort of like dreamy look.
Yeah.
But usually it's something you want to avoid.
So it's like the edges of the photo are kind of fading to black.
Yeah, exactly.
Okay.
Can they fix that?
That's interesting. Can they fix that?
Yes, thankfully.
Okay.
Lens design and software corrections can actually minimize vignetting.
Wow.
So modern lenses are often built to counteract it, and then the camera software can even help further during image processing.
So it's a team effort.
It is, yeah. Hardware and software working together.
That's really cool.
Yeah.
Now, what about color shading?
So color shading, sometimes also called color casts.
Okay.
It can make different parts of an image look like they have slightly different colors.
Okay.
For example, you might notice that the center of a photo looks warmer or cooler than the edges.
Like when the middle of a picture has a yellow tint?
Yeah.
And then the edges are more blue.
You got it.
Yeah, okay.
And like vignetting, it's often due to the complexity of how lenses work and how they interact with light. Yeah.
And thankfully, it can also be minimized through careful lens design and software adjustments.
It's incredible how much work goes into making our photos look their best.
It really is.
Like, it's so easy to just forget about all that when you're just snapping a quick pic.
It's all happening behind the scenes.
Yeah.
Yeah.
And we haven't even touched on color accuracy.
Oh, that's a big one.
Yeah.
Which is all about making sure the camera captures those colors as they truly appear in real life.
Right, because we don't want our photos looking like they've got some weird filter on them. Exactly. What are some of the things that they have to consider to get those colors accurate?
Yeah, so like we want the colors in our photos to match what we actually see with our own eyes, right?
Exactly. And the presentation mentions 3 key things that they focus on when it comes to color. Color accuracy, saturation, and white balance.
Okay.
So color accuracy is all about how faithfully the camera reproduces those colors.
Okay.
Saturation is about how intense or vibrant those colors are. And white balance, that's all about making sure that whites actually look white.
Okay.
Under different lighting conditions.
Oh, yeah. I've definitely seen pictures where the whites look a little off. Like you take a picture of someone wearing a white shirt indoors, and it looks kind of yellowish.
Exactly. Yeah, and getting that white balance right is really important for natural-looking photos.
For sure.
And to test all this, they actually use a 24-color card.
Okay.
And the special tool that visualizes any deviations.
Wow.
So they can really see how those elements impact the image.
It's like they're giving the camera a color vision test.
Pretty much, yeah.
I love it.
It's really interesting.
What other aspects of image quality do they analyze in the lab?
So another big one is SNR, which stands for signal-to-noise ratio.
Okay, signal-to-noise ratio.
Yeah, and it basically measures how much clean image signal there is compared to unwanted noise.
So this is about that graininess you sometimes see in photos, especially when it's darker?
Exactly, yeah. And a high SNR means you're going to get a cleaner, smoother image, even in challenging lighting.
That makes sense.
And they measure this by looking at the uniformity of those color patches and seeing how much noise is present.
Okay, so the more noise, the less detail you can see.
Exactly.
It's all about finding that balance.
Yeah, you need enough light for a clear image, but you also want to minimize that noise.
Absolutely.
Okay, so another thing they look at in the IQL lab is auto exposure.
Okay, auto exposure, what is that?
So that's basically how the camera automatically adjusts settings to try to find the best brightness for a scene.
So the camera is making decisions about how much light to let in.
Yeah, exactly.
Wow, that's so cool.
And stability in auto exposure is really important.
Okay.
Because you don't want the brightness of your video to be jumping around.
Oh, right. Or your photos to be like, one's super bright and the next one's really dark.
Exactly. And the presentation actually shows an example of that when the auto exposure is struggling to find the right balance. And it really highlights just how important that feature is.
I've definitely seen videos where the brightness keeps changing, and it's super annoying.
Yeah, it's really distracting.
So it sounds like we've covered all the tests that happen inside the lab.
We have.
That controlled environment.
Yep.
What about that real-world testing they talked about?
Right, the IQ field tests.
Yeah.
So this is where they take those cameras out of the lab into all sorts of different situations.
Cool.
And they're capturing photos and videos in different locations, different lighting conditions, just to see how they perform.
So they're really putting these cameras through their paces.
They are.
It's not just that pristine lab setting.
No, they're going out into the wild.
Exactly.
Yeah.
What are some of the places that they go for these real-world tests?
So they mentioned testing in offices, underground parking garages, even simulating the lighting you'd find at an ATM.
Wow.
They also look at specific textures, like floor tiles, to check for any distortion.
It's like they're trying to think of everything.
They are, yeah. They want to cover every possible scenario.
So what exactly are they looking for during these field tests?
Well, they highlighted a few specific ones.
Oh, okay.
So in offices, they're really looking at how well the cameras handle vignetting.
Right, in that even lighting we talked about.
Exactly. They want to make sure those lens corrections are actually working in the real world.
Makes sense. It's one thing to fix it in the lab.
Yeah.
But it's another to see how it actually performs.
Absolutely.
What about those parking garages? What's so special about those?
So parking garages are tricky because you have that low light, high contrast situation.
Yeah, that's true.
And they specifically mention testing how well the cameras can read license plates in those conditions.
That makes a lot of sense, especially for security cameras.
Yeah.
You need to be able to see those license plates clearly.
Exactly. Yeah. For security and parking management, that's crucial.
Absolutely.
They also simulate the lighting conditions at an ATM.
Okay.
Which can be really difficult because of all the backlighting and reflections.
Oh, yeah. I've definitely struggled to take pictures of people standing in front of a bright window.
It's a classic problem.
The background always gets blown out.
Yeah, it's tough.
And their faces are completely dark.
And the presentation emphasizes that this is where dynamic range and exposure control are really crucial.
It sounds like it's not just about having a fancy camera.
Right.
It's about having a camera that can adapt to these different situations.
Absolutely. Yeah, it needs to be smart.
Okay, so what else? What about nighttime scenes?
Yeah, so of course they test nighttime scenes as well.
Okay.
Which is challenging for any camera.
For sure.
And they're looking at how well the camera performs in low light, how much noise is there, and how much detail it can capture in near darkness.
Wow, well, we've covered a lot of ground today.
We have.
It's incredible to see how much goes into making sure that our cameras are capturing the world.
Yeah, it is.
In the way that we see it.
Yeah.
What stands out to you the most from all this?
You know, I think what's so fascinating is that this deep dive has really shown us the incredible effort that goes into achieving high-quality images.
Yeah.
It's not just marketing hype.
Right.
There's a lot of science and engineering behind it.
Yeah.
And testing plays such a crucial role in making sure that your camera can handle anything you throw at it.
Absolutely.
And produce the best possible results.
I totally agree. It's easy to take our cameras for granted.
Yeah, for sure.
But I feel like I have a whole new appreciation now for everything that goes into making those amazing photos and videos.
And I think that's the takeaway here.
Yeah.
So next time you snap a picture, just think about all the work that went into making that moment look its best.
That's a great point.
From those meticulous tests in the lab to the real-world scenarios, all of this is happening behind the scenes to ensure that your camera captures the world exactly as you see it.
That's all the time we have for today. Thanks for joining us.